Let's verify a trig identity. We want to verify that the following equation is an identity. And what we have is cotangent theta plus 1 equals cosecant theta times cosine theta plus sine theta. I'm going to work with the right-hand side and start by writing cosecant as 1 over sine theta using a reciprocal identity. As a second step, I'm going to distribute 1 over sine into the parentheses to get cosine over sine. Recall that cosine would then multiply the numerator of the fraction, and then 1 over sine times sine is sine over sine. Now cosine over sine is cotangent theta, and sine over sine is 1, and I have verified the identity by working with the right-hand side. Another way to verify an identity is to use a graphing calculator. So what we're going to do is we're going to go to our calculator. All right, in y1 we're going to put the left-hand side, which is cotangent x plus 1. So we need to put 1 divided by tangent x plus 1. In y2 we'll put the right-hand side, which is cosecant, or 1 divided by sine. Now I'm going to put that in parentheses itself, times cosine x plus sine x, making sure I close all. I forgot my x there. Let me put the x in. And I want to close one more set of parentheses. And now I'm going to check a window, and let's see, I have negative 2 pi to 2 pi. This 0.78 is pi divided by 2, and negative 4 to 4. And I'll take a look at a graph, knowing that I could change the window if I needed to, or if I was unhappy with the graph I'd chosen. And what I see is confirmation that y1 and y2 are the same graph, and that supports my verification of the identity. Let's verify an identity. We want to verify tangent squared times 1 plus cotangent squared equals 1 over 1 minus sine squared. I'm going to work on the left-hand side, and as a first step, distribute tangent squared to end up with tangent squared times 1, which is tangent squared, plus tangent squared times cotangent squared. Now recall that cotangent squared is the reciprocal, well, cotangent is the reciprocal of tangent, so tangent squared times cotangent squared is 1. And making that simplification, I end up with tangent squared plus 1. Now tangent squared plus 1 by the Pythagorean identity is secant squared of x, and secant is the reciprocal of cosine, so secant squared is 1 over cosine squared. And using another Pythagorean identity for cosine squared, and recalling that this is what I'm trying to end up with in verifying my identity, for cosine squared, I'm going to put 1 minus sine squared, and I verified the identity. Let's verify an identity. We want to verify that tangent t minus cotangent t all over sine t cosine t is equal to secant squared t minus cosecant squared t. Well, I'm going to work on the left-hand side, and I'm going to break this fraction into 2 by taking 1 over sine t cosine t times tangent t, and that same fraction times cotangent t. I'll write it as tangent t times 1 over sine t cosine t minus cotangent t times 1 over sine t cosine t. Now the reason I've done that is that I can write tangent as sine over cosine. So this part is sine t over cosine t times 1 over sine t cosine t. Cotangent is cosine t over sine t times 1 over sine t cosine t. And I see that some things simplify. Here's sine t, that simplifies. Cosine t simplifies. And so I have 1 over cosine squared, cosine times cosine, minus 1 over sine times sine, which is sine squared. and 1 over cosine is secant, so 1 over cosine squared is secant squared. 1 over sine is cosecant, so 1 over sine squared is cosecant squared. And that's the right-hand side of the identity that I was trying to verify. Let's verify a trig identity. We want to verify that cosine over 1 minus sine is equal to 1 plus sine over cosine. Now we can work with either side. I'm going to work with the right-hand side and multiply the numerator and denominator by 1 minus sine. Not this 1 minus sine, but the value 1 minus sine over itself. So numerator and denominator of the right-hand side are being multiplied by 1 minus sine x. That makes the numerator equal to 1 minus sine squared if you multiply those out, x, and that's still over cosine times 1 minus sine x. But by the Pythagorean identity involving sine and cosine, 1 minus sine squared is cosine squared of x. So I have that over cosine times 1 minus sine x. And if I simplify a factor of cosine in the numerator and denominator, I end up with cosine x over 1 minus sine x, which is exactly the left-hand side, and I verified that identity. Let's verify an identity. We want to verify that secant alpha plus tangent alpha over secant alpha minus tangent alpha is equal to 1 plus 2 sine alpha plus sine squared of alpha all over cosine squared alpha. Well, this time I'm going to work on the left side alone and the right side alone and work each side till they end up with results that are the same. So let's start with the left. Looking at the left, I'm going to change each individual part to sines and cosines. For secant, I'm going to write 1 over cosine alpha. For tangent, sine alpha over cosine alpha. And then underneath the same thing, 1 over cosine alpha, but that'll be minus sine alpha cosine alpha. And then within the big fraction, I see individual little fractions with denominator cosine. So I'm going to clear the denominator on all these little fractions by multiplying the top and bottom of the big fraction by cosine alpha. So as I distribute that on top, the top becomes 1 plus sine alpha, because the cosine simplifies with this cosine, the cosine simplifies with that cosine. And in a similar fashion underneath, if I distribute, I end up with 1 minus cosine times sine over cosine is sine. Now I'm going to stop working on the left-hand side for a moment at that point, and I'm going to move over to the right-hand side and see if I can do some things to it to make it end up looking like 1 plus sine alpha over 1 minus sine alpha. So here's the right-hand side, and I need to do some things to it. The first thing I see is that the numerator factors into 1 plus sine alpha squared, and I have that over cosine squared of alpha. Now cosine squared of alpha is, by the Pythagorean identity, 1 minus sine squared. So let's keep the numerator for a moment, 1 plus sine alpha squared, but write the denominator as 1 minus sine squared of alpha. Now the numerator's already factored. The denominator is a difference of squares, and it will factor, and one of its factors will be 1 plus sine alpha. So let's factor the denominator. The numerator's going to stay 1 plus sine alpha squared. The denominator is 1 plus sine alpha, 1 minus sine alpha. So by writing the denominator this way, I can simplify a single factor, numerator to denominator, of 1 plus sine alpha, which will leave me 1 plus sine alpha over 1 minus sine alpha. That is exactly, let's look back at our other sheet, the result that we got when we simplified the left-hand side. We simplified the left-hand side to 1 plus sine alpha over 1 minus sine alpha. We simplified the right-hand side to 1 plus sine alpha over 1 minus sine alpha. So we verified that identity. Let's look at an application problem. Tuners in radios select a radio station by adjusting the frequency. A tuner may contain an inductor L and a capacitor C as illustrated. And what you can see is this is a symbol for an inductor and a capacitor. The energy stored in the inductor at time t is given by L of t is equal to K sine squared of 2 pi capital F t, and the energy stored in the capacitor is given by C of t equals K cosine squared 2 pi capital F t, where F is the frequency of the radio station and K is a constant. The total energy in the circuit is given by E of t equals L of t plus C of t, and what we want to do is show that E is a constant function. Well, here's the information we have. We have that L of t is K sine squared of 2 pi F t, C of t is K cosine squared 2 pi F t, and E of t, the thing that we want to show as a constant, is L of t plus C of t. So for L of t, we'll put K sine squared 2 pi F t. For C of t, K cosine squared 2 pi F t, and we need to conclude that that's a constant. What I'm going to do is factor K, and then I'll have sine squared of 2 pi F t plus cosine squared of 2 pi F t times K. Recall that sine squared of an angle plus cosine squared of the same angle is equal to 1. And so this is K times 1, which is K, and we've shown that the energy is equal to a constant.